Hi everybody! Welcome to the video tutorial for launching the Oled module with Arduino. In this video, we first start with an introduction to Oled and its technology compared to the LCD, and we try to provide a guide for the Oled selection in the projects. Then we will introduce the popular modules in the market, and after purchasing the products needed, we will train you to complete the coding process to display a variety of elements, including text, photo, and animation. An organic light-emitting diode OLED is a high-contrast and high-resolution display. American physical chemist Ching W. Tang and Steven Van Slyke built the first practical OLED device in 1987. Nowadays, we can see upgraded generation of OLED like Super AMOLED and AMOLED Plus of Samsung and POLED of LG. There are many options to choose a display: LCD, OLED, 7-segment, dot matrix, and etc. The most important factor that affects the choice of display type is its application. But if you want to display any data or image without limitation on your display, the best choices are OLED and LCD. You need to know the advantages and the disadvantages of LCDs and OLEDs to select the proper display. Many parameters should be checked to compare the displays. In most of the parameters, the LCDs and the OLEDs have the same status, so we only compare the parameters which clarify the difference between these two displays. Brightness. LCD is better in this feature because the whole screen can be brighter. OLED can't do a full screen with as much brightness. Light output also plays a big part in high dynamic range. Black level. OLED wins here because of its ability to turn off individual pixels completely. It can produce truly perfect black. Contrast ratio. Contrast ratio is the difference between the brightest and the darkest a display can be. OLED is the winner here because it can get extremely bright and it can produce absolute black with no blooming. Viewing angle. One of the main downsides of displays is a change in picture quality if you sit away from dead center. OLED is better because OLED doesn't have the off-axis issue LCDs have. Its image looks basically the same even from extreme angles. Energy consumption. LCD is better, but you can decrease the energy consumption of OLED by decreasing brightness. Screen size. If you want to have a large variety of screen size to choose, LCD is your only option. Price. LCDs are cheaper, but OLED will get cheaper. LG has already dropped the price of OLED sharply several times. And the picture quality. OLED wins for overall picture quality due to its incredible contrast ratio. You can choose a suitable display by checking the parameters above. We choose a 128 by 64 0.96 inch SPI OLED display with SST1306 driver and Arduino Uno as a controller and some jumper wires and breadboard to complete the wiring of the circuit. You can get all the necessary components from the Electropeak online shop. The purchase links are placed in the description, but if you're not able to buy the components, you can use the Proto software to test the module. Take a look at a map for the interface of OLED and Arduino. As we said before, our module supports the SPI connection, but the problem is that in different modules, different names are chosen for the pins. For example, the clock pin is also written as D0, SCK, or CLK in some modules. We try to use all the different names here. First, we connect the VCC pin of the module to the 5-volt pin of the Arduino, and also connect the ground of the module to the ground of the Arduino. Connect the D1 data or MOSI pin to the pin 9, the D0 or SCK or CLK or clock pin to the pin 10, the DC pin or data command DC to the pin 11, the CS or chip select SS pin to the pin 12, and finally the res or reset RTS pin to the pin 13 of the Arduino. If you don't have a lot of free pins in your Arduino, you can use the I2C module and connect it to only two pins A4 and A5 of the Arduino. Now connect your Arduino to the PC and get ready to write the code. For easier use of the module, there are various Arduino libraries. We suggest using the Adafruit library. You need to install two libraries to use Adafruit code. First, open the Arduino IDE and enter the sketch from the above menu and select the Library Manager option from the Include Library tab, or you can use the Ctrl-Shift-I. In the Library Manager window, search for Adafruit SSD1306 and install it. Then search for Adafruit GFX and install it. Now open the example in the File menu and look for the Adafruit 1306 and then select the code appropriate for your module. For us, the SPI is 128 by 64. Now upload this code on your Arduino and see the results. At the beginning of the code, there is a comment about the type of the Oled and the license of using this library. Then there are included four libraries named SPI, Wire, GFX, and SSD1306. SPI and Wire libraries are installed on the IDE by default. In the next two lines, the dimensions of the display are defined in pixels with the names screen width and screen height. In the next part, there are codes for defining the pins and adding them to the display object defined here, which is written for both software and hardware SPI, and the hardware version is commented. If your wiring is the same as ours, you don't need to change this part. In the next line, the number of snowflakes is defined as 10, which is related to the animation function and will be explained in the future. In the following, the length and the width and the hex code of the logo are written in binary, which is related to the BMP function, and we will explain it in the future as well. Enter the setup function. The baud rate of the serial port is set to 9600 and you need to set the terminal to 9600 for the code prints. In the next part, display.begin will run, which is in the case of an error in connection with the module, will print the SSD1306 allocation failed statement in the serial port and it gets stuck in an infinite loop. If the connection with the module is correctly set, the run of display.display displays the Adafruit logo for 2 seconds. Then display.clear display clears the screen and display.drawPixel and display.display turn on a pixel at the coordinate of 10 and 10 for 2 seconds. You should have noticed that to display each element after calling the corresponding function, you need to call display.display. In the next section, you will see a list of 15 different types of functions called for drawing various elements. All these functions are called below the loop. Let's check the first function, which is the test draw line. As you can see, all the functions first clear the screen after defining their local variables. This function, with two for loops and with the definition of two coordinate points in the display.drawLine function, draws lines continuously for 4 times in different directions. The display.drawLine function has 5 input arguments. The first 2 referring to the start point of the line, the second 2 corresponds to the end point of the line, and the 5th is for the color of the line. The next 2 functions, testDrawRect and testFillRect, are for drawing a blank and a solid rectangle. This is done by calling the display.drawRect and display.fillRect functions. Both of these functions have 5 input arguments. The first 2 referring to the start point coordinates of the rectangle, the third is the width, the fourth is the length, and the fifth is the color of the rectangle. The next 2 functions, testDrawCircle and testFillCircle, are for drawing a blank and a solid circle. This is done by calling the display functions display.drawCircle and display.fillCircle. Both of these functions have 4 input arguments. The first 2 are the coordinate of the center, the third input is the radius, and the fourth input is the color of the circle. The next 2 functions, testDrawRoundRect and testFillRoundRect, are like rectangular drawing functions except that they plot rounded rectangles. This is done by calling the display functions display.drawRoundRect and display.fillRoundRect. Both of these functions take 6 inputs. The first two are the rectangle start point coordinate. The third input is the width, and the fourth input is the length of the rectangle. The fifth input is the amount of rounding the corners. The more it is, the corner are rounder. The sixth input is the color of the rectangles. The next two functions, test draw triangle and test fill triangle, are for drawing a blank and a solid triangle. This is done by calling the display functions display.drawTriangle and display.fill triangle. Both of these functions take 7 inputs. The first 3 pairs are the coordinate of the triangle corners, and the 7th input is the color. The next function is to display a character. Before displaying a character, you can change its settings such as size, color, and print location. The display.setTextSize function defines the size with the smallest value of 1. The display.setTextColor function specifies the color, and the display.setCursor function specifies the location of the print. Then you can print your characters by calling display.write function. The next function is testDrawStyles and can display the various formats of your data. For strings, you need to insert it into brackets, and for hex, you need to add the hex array to the input. The next function is the testScrollText function. After displaying your data, you need to use this function to scroll. Use start scroll right to go right, start scroll left to go left, start scroll diag right to go up and right, start scroll diag left to go up and left, and stop scroll to stop the scroll. The next function is the testRapidMap and used to display an image. As you first saw, the photo was converted by the software to the hex code and placed in the form of a matrix named logo_bmp in the code. You can print the photo on a screen by calling the drawBitMap function. This function has 6 inputs. The first 2 are the coordinates for the start of printing. The third is the name of the photo matrix. The fourth and the fifth are the length and the width of the image, and the last input is the color of the image. Finally, the last function, testAnimate, is used for creating animations and moving photos. In this code, the same image of the previous function in the form of snowflakes move down the screen from the top. In addition, using the invert display function, you can invert the colors of the element on the page. Okay, let's check out the code. Open a new sketch. At the beginning of the code, add the required libraries: spi.h, wire.h, adafruit_gfx.h, and adafruit_sst1306.h. Then we have to define the length and the width of the display, and also define the Arduino pins and create the display object. We write all our comments inside the setup function and leave the loop function empty. At the beginning of the loop function, set the baud rate to 9600 and add the initial code for the display. Now everything is ready to write the comments and show our elements. First, we clear the screen so that no image has been left on it. Now we want to display some points, lines, and geometric shapes. We start by displaying 3 points in different coordinates of 10, 10, 10, 20, and 20, 10, and then upload the code. To display each element, you need to display it separately, so after each comment, you have to call display.display. Now we want to draw a narrow line below these points. We do this by the drawLine function and entering the coordinates of the start point and the end point of this line. Now we want to draw 2 rectangles, one solid and one blank. We can do this by entering the coordinate of the start point and the length and the width of the rectangle in the drawRect and fillRect functions. Now we want to draw 2 circles, one blank and one solid. We can do this by entering the radius and the coordinate of the center in the drawCircle and fillCircle functions. Now for drawing 2 rectangles with rounded corners, one solid and one blank, we enter the coordinates of the start point, the length, the width, and the amount of rounding the corners in the drawRoundRect and fillRoundRect functions. And finally, drawing two triangles, one solid and one blank. We can do this by entering the coordinates of the triangle corners in the draw triangle and fill triangle functions. Now it's time to show an image. First, we need to take a picture and then convert it to the hex code with the help of the image to hex code converter software. Before configuring the photo, check the settings for the software and make sure that the settings are set. The software link is placed in the description. Now add the hex code to the Arduino code, and after clearing the page, we call the drawBitMap function and enter the coordinates of the start point of printing, the name of the image and its dimensions. And finally, we want to make an animation. Have a Christmas tree and snowfall on it. First, we need a picture of a Christmas tree and a snowflake. Resize the images as it said in the previous part and convert it to the hex code with the software. Now, after writing the initial code of the display and adding the hex code to the original code using the drawBitMap, we can display the tree image. Now, using the library's ready-made code, we want to move the snowflakes on the screen. Add the testAnimate function to the code. By changing the name of the photo and a small variation in the number of snowflakes and the direction of precipitation, we can add snowfall to the image. The link to this function is located in the description. If this tutorial is useful for you, like the video and write to us what kind of information do you display on Oled. And at the end, please don't forget to subscribe. Have a nice time.